Okay. Uh, Still missing some papers. Okay. Mm. Okay, now let's get started. Wait. Okay. Today's our topic is inverse. Okay. So what is the inverse? We have to explain. Okay. All right. The inverse is what? Looks like this one. We have a system over here. The system has input x and output y. Okay. For example, so I'm going to use this one 2x over here. This is f of x equals 2x. Okay. So when you put this number x in there, okay, we can see that always we got one variable y. That's right. Because this is always y equals 2x, isn't it? If this is y to the 1, that is one variable y. Okay, for any variable x, we never find to get two variable y. Anyway, 2x is what? Functions. Okay. For examples, if we have for one variable x, if we have for examples, if we have two variable y, so this system is what? Wrong, right? Because the system is what? For one variable x, always the output should be 1, okay? It can be 2. For examples, if this is thermometer, okay? When you push the button over here, this button check the hours, okay? 12 hours at noon. They're gonna show the temperature, okay? If that temperature is what? Two different temperature, 20 degree, okay, no, Fahrenheit, 60 degree, and another one 75 degree. But this is the wrong device, because what? This is badly designed. Okay, at 12 o'clock, output should be 1, right? Okay, temperature cannot be 2. So this device is wrong, right? Okay, so this is a function. If you got the one output, that the system is okay. So that is your functions. Okay, but what is the inverse? We're gonna find, okay, for example, if x is 5, output is what? When you have an input, the system will multiply by 2 and take them out. That is 10, right? Y equals 10. It's okay. Now the next one, you gotta go back over here. From here to go back over here. Using this number 10, we're gonna find, okay, output equals to 5. Okay, this is what? Backward. This is a forward systems. This is backward systems. Here, okay? So from here 10, you're gonna find output. We use x is input. Now x is 10, y is the output. Okay, we're gonna find these numbers. This system is called what? Inverse, backward. Okay, but inverse is not like 2x. Okay, so how can you find inverse? In general, we use the x is input, y is output before. Now this is what? Change to x. Okay, that's now input. Y is now input. So when you have system over here, this is y equals 2x. To find the inverse, we can switch y to the x. X now output 2y. Okay, from here we can express y in terms of x. Y equals how much? 1 over 2x, isn't it? This is the way we can find inverse. Okay, 1 over 2x. That is okay. So now put this number into the x. 1 over 2 times x is 5. That's right. Okay. So this system can be used for forward and the backward too. Okay. So that's why the design of this system must be expensive, right? We can use both ways, from A to B or B to A. Okay. So to avoid what the difference, okay, this f of x, actually this y totally different. Okay, that's why after you find y, this is replaced with what? F minus x. That means what? This is backward system of original, okay? This we said inverse function, okay? Inverse. So to find the inverse, always switch in x and y and express y. That's the step. That is okay? Okay. The next one I'll be here. Okay, one-to-one functions. One-to-one means what? Forward, backward, always function. That is one-to-one. Okay? So put one value of x, one value of y, one value of y from here, now one value of x. Okay? For example, over here, y equals x squared. If you have a system y equals x squared, this is y, this is x, this is x. The system is now f of x equals x squared. Okay, this is y. When you put this number, x is 2 over here. When x equals 2 over here, y equals how much? 4, isn't it? That's right, 2 squared is 4. Okay, only one output is okay. But we're gonna check it out the inverse systems. Inverse systems, we're gonna check right from 4 to find the 2 over here, right? Now check it out. This is switch x, y equals x squared, but this is y changing to x. This y x changing to y. Okay, that's the way we can find inverse. So when you have f of x, replace it with y. Okay, so x squared. Now step 1 is switch in x and y, so x equals y squared. It's okay. Now express y. Y squared is x. How can you find y? Square root is what? Plus minus x, isn't it? This is y equals now plus minus x. So this one is system is what? It's the inverse, right? Inverse equals 2 plus minus x. Okay. Alright, now put this number in there. Okay. When you put this number in there, I'm sorry, plus minus square root x, okay? I forgot. Square root x. Plus minus. Now, put this number x is 4 there. We have 2 value output, right? Plus minus square root 4 is what is that? Plus minus 2 is okay. One is a plus, the other one is 2. Okay. But inverse is okay, but inverse is not a function. This is not, inverse is not a function, okay? But this one is not one-to-one, okay? One-to-one means what? For one value of x, one value of y, and the reverse way also one value of x, one value of y too. Okay, that is we said one-to-one function, okay? But y equals x squared, that is a function, we know that. This is a function. One value of x, one value of y. Maybe you can use the vertical line test. That's fine. But its inverse looks like this way. This is the inverse. Okay, y squared x graph looks like this one. But this one failed to a vertical line test. For one value of x, two value of y. Okay. So this system only can be used forward. It can be used backward. Okay, because the system is wrong. Is it okay? So only one-to-one function is what you can use the forward and the backward both. Okay? Function is about only one way, right? It's okay? That is one-way functions. But one-to-one function means what we can use the system backward too. Okay? Okay, that's the definitions over here, one-to-one functions. This is a function. A function means what? For one value of x, there will be only one value of y. Okay, but this function also one-to-one. Every element of range corresponds. Range is what? The value of y. Backward, right, to find the x, but x value it should be only 1, right? When you have this one, y equals x squared. If x equals 2, y is one value of y, okay, which is 4, isn't it? But when you have a one value of y is 4 over here. Y equals 4 over here, backward. This is now, okay, input of inverse, okay? when you put this number 4 into the input, it's gonna have a two number over here. One is 2, the other is negative 2. Okay, so this system y equal x squared, this function is not one-to-one functions. Okay, this one only can be used for only one wave function. It's okay. It can be go back. We cannot use from back to the from here to backward. Okay, backward is impossible because when you have new value of y equals 4 over there, x equals plus minus 2. All right, that is not one-to-one. So meaning is only over here one-to-one functions has only inverse function. Okay, it's inverse also function. Okay. Now check it out over here. Okay, we have some exercise one. We have 4 tables. Okay, one represents a relationship between y is a one-to-one function of x. Determine which table represents one-to-one, right? But take this one. When x is 4, that is 2. When x is 4, negative 2. This is what forwarding is failed too, right? That is not function anymore. Okay, because when x value 4 has two different values of 2. This is a forwarding systems, not anymore function. Okay, this is not a function. We don't. This is not a function means what? It's inverse. We don't care, right? Okay, that is not a function. The second one is they are all different, right? Okay, negative 2 is 1. Okay, negative 1 is 0. 0 is only one number. 1 is two number. Okay, that's fine. But this way from x to the y, this way is a function. It's okay. Now I'm gonna go back over here. We're gonna go back from this way. But this is a change to x. Okay, this is a change to y. We're gonna go back. Okay, input is always what represented with x. Okay, not write down one more time. 1, 0, 1, 2. This one is negative 2, negative 1, 0, and 1. Check it out. From here, one has negative 2. Another one over here, 2. For one value of x, we have two value of y. Backward is not function. Okay, this is wrong. So this system can be used only forwards. Okay, from left to the right available. Right to the left is not working. Okay, that is not a function. It's okay. Can you see that? One has negative 2. Another one has a 0 also, right? We have two different values of y in reverse system, which is the inverse. Okay, that is not one-to-one. Not the next one. They are all different value of y. 1 is 2, 2 is 4. Only one value. Okay, 2 is 4, 3 is 8, 4 is 16. That's fine. This is a function. This is okay function. Now backward. 2 is 1. Okay, this is now x. Okay, backward. This is x. This is y. 2 is 1. 4 is 2. 8 is 3. 6 is 4. There's no same value of x. Okay. Yeah, this is okay too. This is also function. This is we set one-to-one function. Okay. Only one-to-one is its inverse is a functions. Alright, if not, its inverse is not a functions. Okay, the system is not a function is what? Not useful. Okay. Negative 3. Over here, we check out the first one. For the same value of x, we have two different values of y. This is not a function. System is fails. Okay, and backward. If this is x now, this is y backward. 10 is negative 3, another 10 is negative 3. Okay, backward is wrong. Okay, the system is totally what? Failed. Okay, it's no use. It is okay. So on the graph, how can you find one-to-one functions over here? One-to-one is what? First one, forward system, we use what? Vertical line test. when you use this vertical line test, if one value of only one intersection of a point, that is a function. That's only what forward this way. Okay, left to the what? Right. Okay, but this is not a function. Forward system already, this is out. Circle is what? Two variable, what? This is out. But this is okay. But now backward over here. Backward is what is that? It's inverse from here. Horizontal line test, okay? Horizontal line test. From here, you got the 4 over here. We have two different variable y, okay? When y equal 4 means this y is actually now x equal 4. This is y, okay? They can switch. Or you can make it inverse, look like this way, okay? After this, we still have what? Two variable y, okay? When you make a turnaround, it looks like horizontal line test to the original, okay? So we applied two tests. Vertical line test, that is a forwarding. Horizontal line test is what? It's inverse. It is okay? But this is not one-to-one, right? This is what? Forward is okay, but backward is what? It's wrong. It's okay. Sorry about that. Okay, this one is okay, right? Horizontal line test. Only 1 point of x. 1 point of x. 1 point of x. This is we set 1-to-1. It's inverse is a function, right? Inverse must be a function. So how can you check it out? Always the original graph is a monotonous graph. If original graph is monotonous. Monotonous means what? All the way increasing or all the way decreasing, one of this one. If the graph looks like this one, it's inverse always a function, okay? Then its inverse is a function. Okay, but take a look first one over here. This graph is function, okay, forwarding function is okay, but its inverse function we're gonna check it out. This is all the way decreasing and increasing again, right? They change their directions. So what this type of function, its inverse is not a function, but original function is a function, okay? Forwarding is a function, it's okay. Go back, that is not a function. Inverse is not a function. This way all the way increasing, okay? Or if we have this one, from here, exponential over here, okay? Or something like this one, okay? Its inverse is what? Always a function, right? Because the graph is all the way increasing. This graph is called a monotonous graph, okay? The graph is monotonous. It is okay? Okay. Now, what's the relation between original and its inverse graph? Okay, for examples, okay, the horizontal line test, okay? To check whether the inverse is a function or not, we use a horizontal line test, okay? So we use this inverse function, we use this system, okay, to avoid what confusion. This is the original, this is the input, inverse. It's okay? One more over here. Existence of inverse function. Inverse is a function. Okay? What is that? If the graph is a one-to-one function, the original is a one-to-one function, its inverse is what? Always function. It's okay? That's it. A second one is, I'm going to explain this one more time. The graph, using the graph, okay? For example, y equals, okay, I'm going to use 5x. That's simple, right? Because the 5x is all the way increasing, we know that its inverse is a function. It's going to be inverse is a function, right? This original function, it looks like I'm going to use this original f of x. But this one also, y equals 5x in general, right? The value of y, output is always 5 times the value of x. Okay, this is the graph looks like this. This is the graph. Okay, this is okay, we're gonna use some y-intercept. You can use y-intercept. I'm going to take this. Okay, y-intercept is 0, so slope is what? 5. Okay, very steep, right? This is y equals 5x. This is also what? F of x equals 5x. That's the original functions there. Now, how can you find the inverse? There's the rule, right? Okay, there's the rule. What is the first one? To find original function, switch x and y. It's okay? Switch in x and y. I'm going to use the word x and y. Because what? This original function, this is x, this is y, forward. But inverse is what? Go back over here. This is now x. So y changed to x, x changed to y, right? That's the inverse. This is original function, this is the inverse function, okay? That's why we switch x and y, okay? When you switch in x and y, we got this one, x equals 5y. Okay, now this is the inverse, but we need to express y in terms of x. Okay, so what is the y? You can divide it by 5 both sides. So y equals 1 over 5x, isn't it? Okay, to avoid the confusion, this y totally different, right? So we replace the what? Inverse. F negative x equals to 1 over 5x. That means what? This one is the inverse of this original. Okay? So the graph looks like, again, I'm going to write this one. F of x equals 5x when you have input x and output y. Now backward over here. Backward. This is now x. This is y. But this one, it looks like, what is that? 1 over 5x. Okay? Okay, maybe you can use the x is 2, y is how much? 10, right? But you're gonna backward. From output, you're gonna find input. Now output changes. Now input is 10, output how much? 10 over 5, or 1 over 5 times 10 is 2, right? Exactly the same numbers. But this system is well designed. It's okay, so this is a two-way system. We can use, right, forward or backward. It's okay. That is good systems. So we switch in x and y. Now let's make a graph of this one. When you make a graph over here, it looks like this way. This is a 5. This is 1 over 5. The graph looks like this way. Okay. This is inverse function equals to 1 over 5x. Slope is 1 over 5. Okay, but this graph is actually symmetrical with this line. Okay, I'm gonna correct this one. Okay, this line. But this line is actually y equals x. Okay, always symmetry with this line, because why? We switch x and y. We switch x and y. X go to y, y go to x. That means y equal, right? So that's why the original graph and its inverse graph always symmetry in this line y equal x. Okay. If we have over here, if we have right, x is 1, y is 5. Okay, we know that because when x is 1, output is 5. We know that. Now switch over here. This is a 5, and this is a 1, right? When x is 5, y is 1. They switch, right? When x is 1, y is 5. But inverse system is when x equals 5, y is 1, right? When x equals 5, y is 1. That is always corresponding, okay? Just before, this was the input, this is the output. Now this is now input, this is the output. Okay? Always you can switch. If we have over some other point over here, okay? Always there's a corresponding side over here. Are you guys okay with this, right? Okay, now let's go back now class node over here, okay? Inverse. This graph is what 2/3 of x minus, so it has the y-intercept. This is the graph. Linear graph is what always all the way increasing or decreasing, which is what 1-to-1 functions. Its inverse must be a function. Okay. It's graphed already. This one is original function f of x equals to 2/3 of x minus 2. Now from here we're gonna find inverse functions. Okay, inverse is go back reverse way. Okay, so we switch x. When you have this one, this is output. First one, when you have f of x, put this one with y. Okay, replace with y and 2/3 of x minus 2. That is original. Now from here it's gonna be inverse. Okay, switch n x on y change to x change to y, 2/3 of y and minus 2. Now our mathematical rule is we need to express y in terms of x always. This is why there plus 2 we got this one, x minus 2 equals 2/3y. Okay, now still we need y, not 2/3. So how can you find the y? Times 3/2 is reciprocal, right? Times 3/2. So this is out, this is out. I'm going to write y the first. Y equals how much? 3/2x and minus 2. We can separate. Okay, slope intercept is okay. That is what? 3/2x minus 3/2 times 2 is what? 3, right? Okay, not to avoid compare this y confused. So we're going to replace with what? F minus 1x. That means what? This system is inverse of this one. Okay? Now check out the graph of this one. Okay. I'm going to different colors over here. Y-intercept is -3. Where is -3? Oops, let me check. Just give me 1 minute, okay? No, it can't be -3 there. Opposite side. I'm sorry, I did. Okay. It can't be -3. This is +2, right? I forgot this one. +2. Okay, +2. That's fine. After that, you multiply. Okay, that is x +2. So this one is +3. Okay, that's fine. Okay, here is the +3. Okay, y-intercept +3. Slope is 3/p is what? 2 right, 2 unit right, 2 unit up, right? 2 unit right, 3 unit up. That is the next point over here. 2 unit right, 3 unit up. That is the next point. Okay. Now with this, we need one additional point to the left. How can you find the left? Follow the right these patterns. 2 left, 3 down from here. 2 left, 3, and that is the next point. 2 left, 3 down, and 2 left, 3 down over here. Okay. When you connect this one, the graph looks like this. Oops. That is not 2 left. 2 left, 3 down, this point, okay? 2 left, 3 down, this point. So I'm gonna make the line over here look like this. Okay, and a little extended this one, looking nice. That's it. Okay. So can you see that some things between these two graphs? Yeah, this two graph is exactly what? Symmetry in the y equal x. Okay, I'm gonna make the line over here. Yeah, there's the y equal x graph. So this one equals y equal x graph. This is y equals 3/2x. I'm going to use the f prime because that is the inverse. F prime f from negative x equals to 3 over 2x plus 3. That's the inverse. This is the original, right? Is actually symmetrical with this line. It's okay? Now we're going to check right some corresponding numbers. If this coordinate how much? When x equals 0, y equals 3, right? When you switch this one, what is that? 3 and 0. It's okay? 3 and 0 should be the other inverse graph, okay? Because we switch x and y. Where is 3 and 0? This point. Okay? When x equals 0, y equals output. Now in reverse way, x equals 3, y should be 0, okay? So also what? 3 and 0 on this inverse line, okay? For example, this point. This point is 2 and 1, 2, 3, 4, 5. This point is when x is 2, y is 6. Its inverse, x equals 6, y should be 2, right? X equals 6, y is 2. This one is when x equals 2, y is 2. Okay? They are always corresponding side because we switch backward. If this is 2, this is 6, backward is y. If this is 6, this one should be 2, right? That's the inverse. Okay? Algebraically determine the inverse of f of x. We did this one, okay? So we're going to have a little more practice over here. Okay, now we have this one. Exercise 1. X minus 3 cube plus 1. For example, x cube, just for x cube, then you graph x cube, right? This graph is translate 3 unit right, 1 unit up, right? 3 unit right, 1 unit up here. The graph looks like here. Okay, this graph is all the way increasing, right? The graph is a monotonous graph. Okay, all the way increasing. Yes, we know that its inverse is a function. Okay. All right. Now we can find the inverse. Okay, switching x and y. The step 1. When you have a f of x is given, we can replace the y, okay? This is means output x minus 3 and q plus 1. Okay? Now, when you switch this one, the moment when you switch x and y, it's gonna be inverse, alright? X equals y minus 3 cube and plus 1. That's now inverse. But this one, y, is not x. This y, okay? Totally different. This y has history. It was before input, okay? The history. Now we need to express y in terms of x. That's the third, okay? So minus 1, I'm going to write this as the first. Y minus cube, that is equals to x minus 1. It's okay? Minus 1. I just write y minus 3 cube number first. After that, we still go few more steps to express y, okay? Cube is what is that? Y minus 2 is 1/3, okay? 1/3 means third root x minus 1. It's okay? Yes? Do you understand this one? 1/3 is what you can use what this one. To the 1/3. Okay? This is what? Fractional exponent is what? Third root x minus 1. Okay? Radical numbers. After that, to express y, you can add plus 3 there. So finally, you got this one. Y equals x minus 1. Okay, I got this one. Radical number. Third root x minus 1 and plus 3. And that's the inverse. Now, to indicate the inverse, we replace with y inverse symbol. Okay, this is the inverse of original. So x minus 1 and plus 3. That's the inverse function. Okay. Now check it out. When x equals 1, I'm going to do when x equals 1, what is the y from original, right? F of x. How much? 1 minus 3 and cube plus 1. Okay? How much is what? Negative 2 cube is negative 8 plus 1 is negative 7, right? When your system over here, when you have a x is 1, output is negative 7. Going back over here, negative 7 should be output is 1, right? Okay, put this number, okay, in the other one. Now, negative 7 is not new input. So x equals now negative 7. This is what f to the what negative x equations. Okay, this is how much? Third root x minus 1 and plus 3. Okay, put this number negative 7 there. F of negative 7 is how much? Third root negative 7 minus 1 is negative 8 plus 3. Okay, third root negative 8 is always a negative number. It's okay, right? So negative 2 times negative 2 times negative 2, it's going to be negative 2 plus 3. It's going to be equals to 1. That's true. Okay? Alright. So follow the procedure, okay, to find how we find the inverse function, okay? First we can check it out. Original is 1 to 1. Now we can go next, okay? How can you find 1 to 1? Just think about its graph. Its graph is all the way increasing or all the way decreasing. It's gonna be inverse functions, okay? Usually they give a right inverse function over here, okay? So just to check that the inverse function over here, okay? This one is graph is what? X over x minus 2, okay? But x cannot be negative 2. That's fine, okay? X cannot be negative 2. Actually, the graph of this one, that's the asymptote over here, and another asymptote over here. But you're gonna learn asymptote later, okay? But not this time. Okay, the graph is, let me see, 0 is 0. They're gonna pass here. The graph looks like this way. Okay, that's the graph. Anyway, okay, I'll show you, okay, the graph, okay, on the online calculator, okay? Anyway, to find inverse, take this as y, set, instead of this one, set y, okay? So x over x plus 2, it's okay? That's a step 1. Now switch an x and y. Now y change to x, x change to y, another y plus 2. Now we're going to express y in terms of x, because we have a 2y up there and in denominator. We need to combine this one, okay? So we multiply y plus 2 both sides. X times y, okay? Times y plus 2 both sides, times y plus 2 both sides. This is out, okay? So y times x is what is there? xy or yx plus 2x. That is equals to y. It's okay. Now I'm going to take this, keep the variable y, because this is here. We're going to move this one to the right, minus yx minus yx. It's okay. Now combine this one. We're going to keep the y in the same side. So y is out. Come on, 1 minus x equals 2x. Now you got 1y, okay? Now how can you find the y? Divided by 1 minus x both sides, okay? So y equals 2x over 1 minus x. That's the inverse. But y replaced with what? Inverse symbol, okay? Because that is the inverse systems. 2x minus 1 minus x. Okay? That's the answer. Which one is equal to this one? Oops. Oh, they use this one. Okay, this is the same thing. Okay, equivalent. They switch x and y. This is minus x minus 1 over 2x. Move this one number up to here. Negative 2x over x minus 1. It's the same thing, okay? That's the equivalent. I'm going to show you the graph of this one, okay? How it looks like this one. But this one is always increasing. Always increasing, okay? But there is a discontinuous over here, but still both the graph is all the way increasing. So there each inverse also a function, okay? I'm going to show you the graph of this one, okay? How it looks like. Just give me 1 minute. Decimal calculator, graphing calculator. Just give me 1 minute. I'm gonna calculate. Okay, you can show the online graphing calculator over here, okay? I'm gonna make a 2 graph over here. The first one is original, okay? There is y equals x over x divide over, right? X over x plus 2. That's the graph. Can you see that over here? Very similar, right? This one, okay? Okay, we have an asymptote over here, another asymptote over here. Okay, y equals 1. The graph is close, 1, negative 1, or negative 2, right? Okay. Now you want to find another one over here. This is a different color. I'm going to y equals. Okay, this is negative 2, so I'm going to do 2x, okay, 2x minus 1 over x, that's okay too. 2x minus over, okay, 1 minus x. Can you see that? That is exactly what? Symmetry in the y-axis. I'm going to put over here one more y equal x, okay? I'm going to put over here y equal x graph. Can you see that? Okay? Exactly what? Symmetry in the y-axis, right? This one, symmetry. This one is symmetry. That's right? Okay. That's the graph, okay? Okay, move on to the next questions over there. Alright, number 1 of the inverse function practice. Okay, we have a graph of negative 3 and 5 on this graph. Because f of x is not defined, just what point is defined. Negative 3 and the 5 over here. This point, maybe you can make a line. Okay, on this line. This is y equals f of x. Original graph. Which point must be its inverse? Its inverse over here, right? Simply this one looks like that's the same thing. Looks like this one, okay? This is what exactly symmetry in the y equal x-axis. But this point, negative 3 and 5 must be on this original graph. Okay? Where the corresponding side is the inverse? Around up here, right? This point must be inverse of graph over here. What is this point? Switch x and y. 5 and 3, negative 3 must be on this inverse graph because we switched x and y, okay? When x equal 3, y is 5 before, but not inverse function is what? When x equal to 5, y should be 3, right? It's gonna be inverse function. The same systems, okay? The same systems. It was a 3, negative 3, 5. Now, if this is a 5 in there, it should be output is a negative 3, right? Same things. Backward is what? Inverse system, okay? Okay, we're gonna have number 2 there. The function y equal f of x is the inverse functions. Yep, they are inverse, that's true. Okay, inverse. F of a equals b, then which of the following must be true? I'm going to make it right, just approximate. When you make this, is okay too. Okay? F of a equals, so what that means? When x equals negative a, y is b. That is the point. Is it okay? Now we have inverse over here. Inverse, when you switch b and negative a, it should be what? B and negative a should be what? The other inverse. This is y equals f minus x, isn't it? Inverse. How can you express the point using what? Function notations. When x is b, put this number b there, y value is negative a, okay? So substitute there. Negative a equals what? F inverse function b. It's okay? Or f more b equals to a, negative a. That's okay. So where is the answer? Choice 1 is the answer, okay? Negative b and a. No, it's not this one. No, negative b. Positive b here. Okay? B and negative a should be on the other graph of inverse. Okay? That's the meaning. Alright, number 3. What is the from inverse to, we're gonna find the original. But it doesn't matter, same as this one, okay? So we switch x and y again, right? Because inverse over here, x and y, original, switch again. Y change to x change to y, that is the original, okay? To find inverse, it's gonna be same method, okay? So this is why, switch x and y, x equals 1 over 2, y minus 3 over 2. But this y is original, right? Yeah, f of x. So we're gonna express y in terms of x. So 1 over 2y equals 2x plus 3 over 2, right? Now to express y, we multiply by 2 there. So I'm going to write y first. Times 2 is what? Y. Times 2 over here, what is that? 2x. 3 over 2 times 2 is what? 3, okay? So this is original now. F of x equals 2x plus 3, okay? That is original functions. Okay, I'll give you okay in a minute. Okay, you guys have some practice to find the inverse. Okay, follow the step. Okay. Can you guys try this one and you can give me the which one is correct? I'm gonna make sure okay you guys understand this inverse function. Okay. So just give me the answers if you find the correct one. Okay. Try number 4. I need this one out. Okay, try number 5. So we have g of x equals 4x minus 5x minus 5 minus x. Find the inverse. Take this as y. Switch x and y. Okay. X equals 4y over 5 minus y. Okay, so multiply 5 minus y both sides. X times 5 minus y. Right hand side 5 minus y cancelled out. We got only 4 over y. Okay. Now we need to express y because we have 2y left and right. We need to combine this one. X times 5 is about 5x. X times y is xy equals 4y. To combine this one move to the right. How? Plus xy, okay? And plus xy. Now you got this one. 5x equals to 4y plus xy. It's okay? Now we can combine the y because they are now in the same side. Y is common. So inside the parentheses what? 4 plus x or x plus 5. Now you can express y, okay, by dividing what? 4 plus x both sides. So what is y? Y equals what? 5x over 4 plus x, but x plus is better looking, okay? That's the inverse. But to represent inverse, we replace with what? F minus x, okay? That's the inverse function. Okay, they use this one, okay? This is g of x, I'm correct, okay? gx is the original, this is g minus 1, okay? That's the inverse. Okay, you guys try out number 6 one more times. After this, okay, well, let me see. You're gonna have a 5-minute break, okay? Okay, try number 6. Inverse of this one. Set this is y first. After that, switch the x and y, okay? Okay, express y in terms of x. That's the inverse. Okay, try this one. Okay, we work together, okay? We don't have enough time. So times y minus 2 both sides. Okay, so this is the xy times 2 times x. Right hand side is what? This is out, we got y plus 1, okay? But now, they all have right positive 2x, okay? We're gonna keep the variable in your left. Okay, that's our scale. xy minus y is a minus y there. This is out. Plus 2x plus 2x. Okay, that is a 2x plus 1 there. Okay, now we got the y in the same side. We can combine the y. Okay, combine the y inside the parentheses. X minus 1 equals 2x plus 1. Okay, after that you can divide by x minus 1. But we have to replace this one inverse. Okay, that's the inverse function. Okay, because there is the original function there. That's the answer. Okay, 2x plus 1 over x minus 1. Choice 2 is the answer. Okay. Okay. We're gonna have 5 minutes break. Okay. Okay. Right. Just give me 1 minute. This one's a pause. Okay. Back to work. Okay, when you have a polynomial functions, okay, it is easy to find the inverse function, right? Because switch in x and y and express y, that's it, okay, in polynomial. And regular functions, okay, in regular functions, we know that how to find inverse. Switch x and y, express y, okay? Switch x and y and express y in terms of x. Okay, that's the inverse. But sometimes we have trouble. Okay, what is that? If we have an exponential function, okay, we have exponential. For example, so y equals 2 to the x graph. That is the exponential function. Okay, because this is a geometric sequence. Okay, when x equals 0, y is 1. When x equals 1, y is 2. When x equals 2, y is 4. When x equals 3, y is 8. Something like that. Times 2, times 2, times 2, right? The numbers is a geometric sequence. Now, our problem is how we find the inverse of this one. Okay, follow the same procedure over here, okay? Switch in x and y. Okay, this is x, now 2 to the y. Oops, y is what? Up here, not first floor. Y is what? Up to second floor. Right? How can you express y? There's no other way. If we have this one, y equals 2y there. This is regular functions there. To find the y, you can divide by 2, right? That's fine. But y is up there. Okay? But anyway, we need to express. We need to express y in terms of x. It's okay? How can you express y in terms of x? There's no other way. That's why we made one new symbol, which is a log. Logarithms. It's just a log. Okay? To express y is down there. We're going to move down y here, okay? So there's a rule there. If we have x equals 2y there, that is exactly equivalent. Y equals, okay? Y equals, we use the log over here, log. This base number move down over here, either down there, and this power up here in the middle. That is equivalent. This y actually what is the exponent, right? Over here, exponent. This one is what? Base number. The x is what? Power, value of power over here. It's okay? That is equivalent. We define this way. You have to memorize this one. When you have x equal 2 to the y, like this one. 2 to the y, no computer, right? Okay, I will delete this. Equal 2 to the y, we're going to express y. Now the y is moving down, right? Y equals what is the log 2 base number and all the way down a bit, okay? 2 base, the log power in the middle. Okay, that is our definitions. Okay? Yeah, that's the way we can find, okay? That is our definition, okay? There's no other reason, okay? This one is equivalent. This is we set exponent form. This is the logarithm form or log form, okay? Or log expression, exponent expression, okay? Take a look here. When you have exponential form, we're gonna have a little practice how we change into from exponential form to log form. This is exponent. We're gonna express y over here, exponent number. How can you find exponent y? Y equals, okay, y equals second is okay. Y equals what is that? Log by definition, right? I'm gonna use this one more time. X equals b to the what? X over here. B to the y. Equivalent what is that? Log base number b to the x, that is equals to y. Okay? That is equivalent. Yeah? So 5 equals 5 okay, down over here. The log, this is base number 2 up here, and the whole things, this number 32, that's the power, right? 32 up there and equals to 5. Okay? By definitions. So we're gonna change the form a little practice. Okay? This is what is the log 5 to the what? Log 5 of 25. We can say log 5 over log base 5 of 25 is 2. Something like that. Okay? Alright, now take a look over here. Log base 4 of 64, that is equals to exponent 3. Can you do that? Now change into log form, okay? So log base number 9 of number 81 is 3 equals what is that? Exponent 2. Okay? Now we're gonna go back from log to exponent. What is that? Base number first. Base number to the what? That is exponent, okay? 10 to the 4th power equals to 10,000. That is true, right? Now, base number 3. Base number 3 for the exponent, that is equals to 81. That is the exponent form. Log 1, that is 7 to the 0. 7 to the 0 equals to what? Power is 1, okay? That is the definitions. There's no other reason, okay? So when you have this one, remember, okay, they are exactly log b to the a, right? That is the base number going to over here. A is going to there, but equal to y is exponent. Is okay? Just to memorize this one. That is our definitions. Okay? So exponent. Okay? This is the base, where is it? Over here. Right? The power is over here. And exponent is always equal. Okay? So the value of log is what is it? Always exponent numbers. Okay? Exponent. Okay, we have some expression over here, okay? Now let's have some practice. Over here, okay, take a look over here. One more, this one, not first. When you have a base number 10, okay, we set common log, base number 10 over here. Okay, for examples, okay, doesn't matter, this one. This one, later we can do that. Just have some more practice, change into exponent into the log or from log to exponent. Okay, this is the log exponential. Okay, the log form. How can you find the exponent? Base number. This is base. Just memorize. This number is base. It was history base. This number is exponent. This number is the power. The evaluation. So what is the base number to the 33 equals what? 64, right? That's the exponent form. Is okay? Now we're gonna put this number into the log. Base number, where is it? 5 is the base number, 5 is there. And the power number is 25, that is the exponent is 2. That is okay. This is the base number, right? But sometimes we have, right, I'm going to use this one, okay, log 10 cube equals what? 1000. It is okay? 10 cube equals 1000. That is the exponent form. Can you find the log form? Yes. This is the base number. Log 10 to the what? The number power is 1000. That is equals to exponent 3. That's true. But when you have a base number 10 over here, this is the base number 10. But this one which occurs a lot. Many times, always what? 10, 10, 10, 10. But in this case, to avoid, right, okay, wasting time, when you have 10 over here, we don't have to write down. We don't have to write this. Just what? Log 1000 equals 3. Okay? Because this is very common. That's why you said log 10. Okay, this we said common log. Okay, this we said common log. Logarithm or common log over here. Common log is okay. Okay? So log 100 is 2. How can you read this one? Log, there's a base number over here, right? Because this is a common log. Log base 10 of 100 equals to 2, right? It's okay? We did already. Okay, take a look. Okay, log base 5 over 25 equals to 2. Okay, just memorize how to read this one, okay? Okay, another one over here. When you have a base number is e, if we have this one, e to the 5 equals to k. Because e is what? A natural number, which is 2.73, okay? That is irrational number. It is not a rational number. So if the value is k, you can express this with log. Log base number is e, and the log power number is k, the number is 5, that is 5, right? That is the expressions. But this number, log e, base number e, this one happened a lot, okay? This is also very common, but because we use a common already, base number 10, this base number e, we use this one, e is one natural number, okay? That's why you're gonna put the name, the different log, natural log, ln. It's okay? ln. This way, n means what? L is log, n is the natural, k. Okay? This is actually log e. Switch to this way. It's okay? So there's a natural log is what the base number is e, okay? So when you have this one, there is a log e, okay? That's the meaning. This log e is what natural log, ln. Okay, we're gonna try this one again, change the form, okay? Alright. B to the x, B, this is base number, log base number, okay? Log base B of y power equals to what? Exponent is x. It's okay? That is the log forms. Now I'm gonna change this one is into the what? Log. This is what? Exponent. Base number is 3 and the power is 9, exponent is 2, right? Sorry that. Log base number, log base 3 over the number 9 equals 2, right? That's it. Okay, that is the log form. The next one is what? This is a log 2 exponent. This is base to the what exponent, right? 2 to the 4th power equals 16, isn't it? Remember, this number is the base. This number exponent. To change what exponent, the base to the what exponent, right? 2 to the 4, that is the power. Okay, the variable what? 2 to the 4. Now 10 to the 3 is what? 1000 over here, okay? This is the base of the number. So we can, base is down over here, of the number is 1000, that is equals to the exponent. Okay, because this is what? Base number 10, because that is a common, we don't have to write. Just what? Log 1000 equals to 3. This is correct, because that's the rule. When you have a 10 over here, we don't write down there. But you can write down, but that is anyway against the rule, okay? 0.1, that is also what? There's no base number, yeah, that is a common, that's why there was 10 there, okay? This is the base, this is the exponent. 10 to the negative 1 equals to a power 0.1, right? That is true. Are you guys okay with this, right? Okay. Now the next one, without using your calculator, determine the values of x in the following equation. What is the value of this one? ln e is how much? ln e, actually this is natural log, okay? It has history, it is what? Log e to the e, right? That we got ln, okay? Okay, you can use this one, x. How can you change? Base number to the x, e to the x equals to power e. What is the value of x? X is 1 there, right? It's okay? So actually, ln e equals to 1. Because the ln e looks like this one, log e to the e, that is the ln e. In the log, base number and power, if they are equal number, always the value of log is 1. That's the rule 1. That is the rule 1, okay? So, log 10 is 1. Because what? Log 10 is a common log. There is the base number. 10 is 1. Log 88 is 1. Log 100 to 100, that is also 1. Always, if the base number, log number always equals, that is 1. Is it okay? Take a look over here. I'm going to use any base numbers. When you have a log, this base number and the power number is equals. This is 1. Why? b to the 1 exponent, but you can change exponent, it's easy. b to the 1 is equals to b. That is true, isn't it? b to the 1 is b to the 1. b equals b, always true, okay? That's why base number and power, they are equals. The value of this one always equals to 1, okay? But in this case, ln e is what? Log e to the e, same number. Anyway, ln equals to 1, okay? And also common log. Log 10 is also what? 1, right? Because there is the base number 10 there, okay? What is the value of this one? Okay, try this one more times. This is base number e there, right? Okay, I'm going to check this one. Log e to the what? E to the 5. Okay, using by definition, okay? That is a base number, that is exponent. E to the x equals to e to the 5. What is the value of x? Same base number, exponent must be equal, so x equals 5. It's okay? This number equals to 5. Okay, now we gotta make a graph over here. We already done, okay, that is inverse. Okay. Oops. I have a bug here. Okay, that's fine. This is a 2 to the x graph. Okay. So you can put over here when x equals 0, y is 1, when x equals y is 2, when x is 2, 2 to the square is 4. Over here, going down it happen, right? Or it's geometry. 1 divided by 2, divided by 2, divided by 2. Keep going. That's the graph of what? Exponential function. Okay? That's the graph. They never touch the what? X-axis. They approach, but never touch. Okay? This is the graph of y equals 2 to the x. Now let's find its inverse graph. Its inverse graph, we already did it, okay? How can you find the inverse? Inverse graph looks like this way. This is y, 2x, okay? So y equals 2x, the inverse should be switching x and y, x equals 2y, but we need to express y. Okay, what is that? Log base number 2 to the power x, that is equals to y, or y equals what? Log 2 to the x. That's the inverse. This is what? F minus x. This is what? F original graph. So this is inverse of this exponential function. Is okay? So start simply by 2 going down here, x is going down over here, okay? That is y. Now let's find the inverse, okay? Inverse switch over here, this is 0, 1, okay? This is what switch in x and y, okay? Always y. This is switch in x and y. When x equals 1 over 8, y equals negative 3. When x equals 1 over 4, switch negative 2. And to switch this one, x equals 1 over 2, y equals negative 1. Now this is a switch, x is 1, y equals 0. Switch x equals 2, y is 1, x equals 4, y is 2, x equals 8, y is 3. Switch is what? That's the corresponding side in inverse function, okay? Using the graph, using this value, we can see the graph over here, okay? The graph of this one, how much? Negative 1 over 8, x equals negative 1 over here. Very close over here. That is a negative 3 here. X equals negative 4, negative 2 over here. X equals negative 2, negative 1 over here in the half. Right? Negative 1 over 2, right? Negative 1 over 2, that is 1. Now x is 1, that is 0, this one, 0. When x is 2, that is 1. When x is 4, that is 2. When x is 8, that is 3, right? Okay? When x is 8 over 1, 2, 3, 4, 5, 6, 7, 8, that is 3, this one. When you make the line over here, okay, the graph looks like this way. That's the graph. Which one? This one, right? It's inverse. Graph equals to log 2 to the x graph. This is a graph of what? 2 to the x graph, exponential. Okay? So log graph always what? Move to the right, getting what? Slope is what? Getting slow, right? Okay? This is what? Move very fast, right? Very steep, very fast, but this is very slow, okay? That's the graph of y equals log 2, log base 2 of x, okay? Okay, to find inverse algebraically, the first step is switching x and y, second step is y express y equals x. That's it, okay? This means what is that? 2 to the y equals to x. That's why 2 to the y equals to x. Same things. That's the graph we did, okay? That is 2 to the x, this is what? Inverse, okay? Okay, we continue about what the inverse graph next time, okay? It's not hard, just we made log only what to express what inverse of exponential function, okay? There's no other way. That's why we made one new symbol, which is a logarithm, okay? So using this logarithm, we can find the next times operation of log, okay? Because what exponential also what exponential operation, you understand? A to the x times a to the y equals a to the x plus y, okay? Something like that, right? A to the y, x minus y, something like that. There is an exponential operation there. And also log also what? Corresponding, there must be log operation too. We don't have to change always the exponential, okay? Sometimes we need to evaluate in the log operation. We're gonna learn this one next time, okay? I think that's all today, okay? So if you guys have any questions, you can email to me, okay? Thank you so much. I'll see you next time. I'm gonna stop.